This is the part 3 of Unit 1, and part 3 is the periodic trends of the elements. So the development of the periodic table. Periodic table is the most significant tool chemists use for organizing and remembering chemical facts. The periodic table arises from the periodic patterns in the electronic configurations of the elements. Elements in the same column contain the same number of valence electrons as what we have discussed in part 2, and the trends within a row or column form patterns that helps us make predictions about chemical properties and reactivity. So Dimitri Mendeley and Lothar Meyer, they arranged the elements in order of increasing atomic weight. Henry Moseley, he developed the concept of atomic numbers and he identified the atomic number. So the modern periodic table, it is an arrangement of the atoms in increasing order of their atomic numbers that collects atoms with similar properties in vertical columns. So the period or the series are the elements in a row. So for example, the period 1 is composed of hydrogen and helium. Period 2 is lithium to neon. Period 3 is sodium and argon, and so on. So fourth, period 5, 6, and 7. Family or group are the elements in a column. So these are the vertical. So group 1A is composed of hydrogen to francium, group 2A from beryllium to radium, and so on. Group 3A, group 4A, 5, 6, 7, and 8A. Group 1B, 2B, 3, 4, 5, 6, 7, 8, 9, 10B. So those are the family or groups. So periodic classification of elements, first is based on properties. So there are two properties in the periodic table, the metals and the non-metals. So metals are the elements in the left side and in the center of the periodic table, while non-metals are the elements on the right side of the periodic table. So as you can see, the periodic tables have different colors. So from gray to pink are the metals, which is the left side to the center. So these are the metals. The blue ones are the non-metals, and the peach one are the noble gases. So next is based on their electronic configuration. So the representative or main group elements. So these are the elements in which the last electron added enters an s or p orbital in the outermost shell, but in which this shell is incomplete. So they are found in groups 1A to 7A. So there is a periodic table, groups 1A and 2A, ang ilang electrons enter the s orbital, while group 3 to group 7A enters the p orbital. So they are called the representative and the main group, or the main group elements. Next is the transition elements. So these are the elements that have filled or partially filled inner d subshell or d orbital. So they are found in groups 1b to 8b. So this group 1, 2 to 8b are the transition elements, or because they have filled, partially filled or filled d orbitals. Next are the inner transition elements. So these are the elements that have filled or partially filled inner f subshell. So they are otherwise known as lanthanoids and actinoids. So these elements are their electrons enter the f orbitals. So they are called the inner transition elements. And lastly, the noble or the inert gases are the fully filled orbitals. So as what we have discussed in part 2, these noble gases are the most stable elements because they have filled their orbitals. So periodic trends. First is the atomic size and the atomic radius. So the atomic size or radius is derived from the distance between atoms when bonded together. So iyahang nga trend is that within each group, so meaning vertical, atomic radius increases from top to bottom. And within each period, atomic radius increases from right to left. So as you can see, si lithium, mas dako siya kaysa kang cesium. So based ani nga picture. So ang trend sa atomic radius or atomic size is that increasing from top to bottom and from right to left. Next is the ionization energy. So the ionization energy is the minimum energy required to remove an electron from the ground state of the isolated gaseous atom. So first ionization energy is the energy needed to remove the first or the outermost electron. So iyahang trend is reverse or opposite sa atomic mass and atomic radius. So kung ang atomic size or ang radius sa atom, sa elements, is from top to bottom increasing. So, opposite kang ionization energy. Increasing ang, within each group, ionization energy increases from bottom to top and from left to right. So, opposite sila ni atomic size or atomic radius. So, next is the electron affinity. So electron affinity is the energy change associated to the addition of an electron to a gaseous atom or ion. So same sila og trend with ionization energy. So increases in electron affinity increases from bottom to top and from left to right. So electron affinity is that large atoms are expected to have low electron affinity because their valence electrons are farther from the nucleus. And small atoms have high electron affinity because added electron will be closest to the nucleus. Fourth is the electronegativity. So it is the ability of a banded atom to attract electrons to itself. So same with ionization energy and electron affinity, and trend ni electronegativity is that it increases from bottom to top and from left to right. Next is the metallic and non-metallic characters. So metallicity or the metallic character, within a group, metallicity increases from top to bottom. So opposite sila ni non-metallicity. So non-metallicity character decreases from top to bottom. Then within a period, metallicity decreases from left to right, while non-metallicity character increases from left to right. So, opposite sila. But as discussed earlier, so these are the non-metals and these are the metals. So that ends our discussion for the whole Unit 1.